Hi, I'm going to be talking about ACI and how it relates to technologies in the open source. In particular, I'm going to talk about OpenStack and containers, in the presentation. But first, I usually like to refer a little bit onto what Mike talked about and give an overview of how ACI, how we're thinking about open source and integration with standards and open source tools in ACI. And we think about them a couple different dimensions, right? One of them is, one dimension we just heard a lot about is our focus on APIs, right? API first. Everything was driven off of REST APIs with APIC, and then we allow you to build different tools on top of that. So for, we're offering a CLI for people that are comfortable with CLI, REST API, different kinds of, Python SDKs, ACI toolkit, a whole bunch of tools so that it's really easy from everyone from, DevOps engineer through, people that are comfortable with GUIs through standard network engineering models to interact with our tools and basically enabling all those capabilities. We've done a lot of work in standards bodies as well. So we've taken all the innovation we've done within ACI and we've started pushing it out to standards. So you'll see talk about OpFlex, which is our standard around distributing policy down to remote devices. How we're bringing that into the open source community. VXLAN GBP is actually our extensions into VXLAN that we use within ACI. We've actually upstreamed that into the Linux kernel now. Stuff around NSH we've been doing inside the IETF. So driving some of these standards back through the standards body so they can appear more generally across the board in the technology landscape. I'll talk a little bit about containers in this presentation and basically how we can enable containers and container technology to work with ACI. In particular, we're doing part of this through driving open source projects. So I'll talk about something called Project Contiv, which is an open source project around delivering policy through a set of Docker plugins and plugins that can tie into Linux containers. And also talk about OpenStack and how we can actually how we've delivered open source contributions into the community to enable policy. And then also made OpenStack work really well on our ACI products as well. So I'm going to start by actually talking in the OpenStack domain and actually drilling in on a project called group-based policy. So the group-based policy basically came from the idea that with ACI, we had done a lot of thinking about how applications should be modeled and how you can differently think about requesting resources from your network. In terms of groups and rule sets that connect them together. And we said, well, this is actually not specific to ACI. It's a generic concept. Actually, everyone can use this. And we created an open source implementation. And group-based policy is that for OpenStack. It actually works with any Neutron plugin. So basically anyone's networking backend can actually sit behind this, but the users can create policy and use that policy to interact with their system. So it's completely open source, compatible with a number of OpenStack distros. We're supporting ACI on it, but really anyone in the community can pick this up and use it as a way of adapting policy into their OpenStack environments. Another piece of it that's actually pretty important and relatively newer is actually a network plugin framework for actually orchestrating network services within OpenStack. So one of the emerging areas that people are often asked for is, well, how do I chain together VMs that are created by OpenStack if they happen to be network services? They might be load balancers and firewalls, and actually want to string them together. We've done a lot of work on this also inside ACI, but more generically in OpenStack, it was still an unsolved problem. So we actually worked with a partner called One Convergence who created a lot of this technology. It's completely open source. Part of the group-based policy project to help you actually run network services and do some network service chaining through OpenStack. Again, this is something we can also use in the ACI environment, but it's not exclusive to that domain. And ultimately, what we wanted, one of the things we brought together was a solution for using ACI on top of OpenStack. And one of the critical pieces of that was OpFlex. I talked about OpFlex as an open standard that we created for distributing policy. It also is an important piece of open source. So we wrote this component called an OpFlex agent. The OpFlex agent is a little piece of software, 100% open source. It actually is formally governed inside the Open Daylight community that allows essentially a remote device, in this case it's ACI switches, to communicate policy down to a device. In this case, that device is the OpFlex agent managing the Open vSwitch. What this lets us do is actually extend ACI out of the physical switching domain, now down into the virtual switches as well. So now Open vSwitch, the standard open source Open vSwitch, been developing in the community, is now a piece of technology that ACI can control. So this lets us do a number of interesting things. It lets us take all of the OpenStack networking that people commonly do and offer it as the fully distributed service on top of our fabric. So this includes things like NAT, floating IP functions that are common in OpenStack, DHCP services that are normally run on specific server inside OpenStack, routing functions that are centralized in many OpenStack deployments, all become completely decentralized components that we can manage in our fabric, both at the physical layer and then also at the virtual layer inside the Open vSwitch, all managed through our OpFlex agent. So we deliver this solution across a number of different distributions. We're actually working, also internally with our Metapod team to be able to deliver this as part of a Metastack solution out of Cisco, in addition to working with the external partners that we've been working with in the OpenStack domain. And of course, we deliver the solution on both the ML2, using standard Neutron APIs as well as the group-based policy work that we've been doing upstream. So we think about that as an API layer. You can choose whatever API you like. Our fabric will work essentially the same way, and our OpFlex components work the same way. Some people like policy, and that's how they want to use OpenStack. They've attracted that idea. Some people are not, and they want to think about it in simpler terms, in terms of how the existing OpenStack is run with networks and routers as logical entities. So we enable both those capabilities, and ACI functions in a relatively similar way in both those environments. I'm not going to do a demo of this piece, so I wanted to give you kind of at least a quick screenshot of what this looks like in practice. So what we added was, in addition to some of the integration you saw with, say, VMware environment or Microsoft environment, we have an integration into the OpenStack environment. So we actually have a VMM domain for managing OpenStack. And as part of this, we can actually show you per hypervisor or per Neutron network information that we pulled directly from OpenStack and from our and through our OpFlex agents into APIC, so we can display it here. And then what we allow you to do is see how that information maps into ACI and into our ACI EPGs. We'll show you, the VLANs that are being used, host information, what port, what actually tap interfaces are created on the host, and how those things all connect together. And then even what encapsulation is used to connect up to the ACI fabric, so that you can ultimately do, through APIC even, network management and troubleshooting, and you have knowledge of what actually got connected and set up on the host. So this no longer becomes like a multi-dimensional problem from a network troubleshooting perspective. We put it all in one place for you. We make it really easy to use APIC and all the standard APIC tools to manage and troubleshoot your network. And on the end, this kind of troubleshooting capability is one of the biggest value adds we bring in the OpenStack environment, because it tends to be an environment with relatively fewer tools for operations and management. It's really good at letting you create stuff, but how you end up managing it in the end is something that OpenStack as a community has not invested as much in. With APIC and ACI, we actually fill that void, and we say, well, OpenStack will create the things for you. We'll be downstream via the API, but then we allow you to handle the operations, and we'll show you when something goes wrong in your network, when your VMs can't ping anymore, we can tell you why. And we can tell you why if it's a physical problem, we can tell you why if it's a virtual problem. Because we have built all these tools inside our fabric with our OpFlex agents down in the hypervisor as well. And beyond that, we can even give you things like stats. We can give you health scores, all the standard sort of APIC tools. You can build tools to alert on these things and see how faults are generated and how they might tie back to the OpenStack environment. I mentioned, we're working with a number of partners in the OpenStack community. So we essentially release a set of open source plugins. We validate them across a couple of distributions, so that we can essentially bring solutions to our customers that actually want to run across most versions of OpenStack. And of course, many of our customers are also doing OpenStack themselves, and we're happy to work with them in kind of pure open source community as well. And I mentioned one of the other things we're working with closely is the Metapod team, who's also joined Cisco, and they sell a managed solution on top of OpenStack. So we're also delivering our ACI solution later this year as part of that. There's a bunch of links here. I know they're small, but I'll leave them up for a second. If you want to learn more about the solution, we have design guides. We have a number of deployment guides. All of our plugins are open source. There's no special licensing for them. You can grab them. You can set them up on your OpenStack environment. So the next piece I'm going to talk about is something called Project Contiv. So Project Contiv is an open source effort in the container domain. So the idea is we actually looked at a lot of the work going on in Linux containers, And there was a huge amount of innovation. It was happening very quickly, very fast-moving space. And we really saw that a lot, again, the concepts we had thought about a lot with policy, were not yet there. Containers were being spun up. They were essentially being connected together in relatively simplistic ways. And no one was thinking about, what kind of policies might govern how these behaviors would interact. Well, we had done a lot of thinking about this, and we'd also done a lot of work in open source community around it. So we started spinning up another project called Contiv, which said, well, let's see what can we bring to bear in the open source domain around managing containers and connecting them to operational policies. So if you think about what Contiv gives you, Contiv gives you a set of policies designed to, one, coordinate with the application intent we get from the different tools like Docker or Kubernetes. They already had some tools to say, I want to create these clusters of containers that might do different things. What they didn't say is, operational policies, how are these things going to actually connect together? How might they interact with the network? How might they interact with storage? And this is where we thought we could add a lot of value. Now, we also saw the communities building plugin frameworks. So this was around the time Docker said, well, we should have a network plugin framework, and we should let people actually write plugins to enable these things. So they did this for network and storage, and we said, well, great, these are the insertion points where we can start adding hooks to manage policies in this domain. And that's exactly what Contiv does. It started with Docker. It actually is extending over to work with Kubernetes as well, and we're making investments in that space. So Contiv itself is completely open source. You can find it on GitHub. There's really great documentation. Again, this is not an ACI specific component. I'll end up showing you a little of it with ACI, but this is, Contiv actually runs in a number of different modes. It runs on our regular NXOS switches. It runs in a pure L3 mode where we route all the way down to the server. It'll run as an overlay, and it also has an integration with ACI where you can use Contiv managed policies in any of those domains, and they're the same policies regardless of how you choose to deploy it. So what do we mean when we talk about policies with Contiv? What do we actually mean, right? So there's two key dimensions where we've been investing. One is around network. If you think about network, you can do, we're looking at things like cluster-wide connectivity, being able to do multi-tenancy. So Contiv can handle overlapping IP addresses and manage them. Of course, this depends on the networking mode you're ultimately connecting to, but its policy structure is rich enough to define different kinds of multi-tenancy modes, security, and how security between containers can be defined. A lot of this, of course, is taken from the concepts of group-based policy that we've been driving. So defining groups and actually policies that connect the groups together. That's a key part of the Contiv implementation. Contiv can handle IPAM for containers. It can handle service discovery. It will ultimately have tools for analytics and diagnostics. And I mentioned it has these multiple deployment models that can work across a range of different networks. So if you have ACI, you can benefit from all the things ACI does. If you want to have a routed L3 network, well, Contiv can also work in that domain. And then on the storage side, there's been also a lot of investment around managing storage and storage volume. So we can do things around allocation, replication, managing snapshots, persistence of the images beyond the life of the containers, IOPS that you might need inside a particular container, storage types, file system types. These are all policies that would get configured. So when you spin up your containers, they would automatically inherit a certain storage policy. So again, this is a complete open source project. It's something that we saw not happening in the community. It's a place we thought we could add a lot of value. And of course, since we're talking about ACI, I want to talk about how Contiv can fit in the ACI domain. I mentioned it had, it's a generic framework, right? So it works across a range of network types. But one of the places it does enable us to do a lot of interesting things is with ACI, because inside ACI, we already have policies. We already have a completely policy-aware fabric, so we can actually bring a rich set of features to bear, and Contiv can help us interface with the users as we do that. So essentially the way Contiv works is it has a component called the Contiv master. Again, it just speaks over the REST API to APIC. In fact, it actually used some of the tools Michael was talking about previously. We have with our Python SDK and call into APIC. And ultimately, it's driven by some of the tools, the container management solutions that you might get from like Docker, Kubernetes, Mesos. Will ultimately be able to drive it and push the policies. It includes a Docker plugin, called net plugin from Contiv, runs on the host, that allows us to do integration at the host level, and then tie that back through the ACI domain. So I want to show, leave you with a couple quick links before I'm going to use the last couple of minutes. I have to do a very quick demo of some of this in action as well, assuming everything doesn't go awry. But I'll leave these on the screen for a minute for people that want to learn more about Contiv. So Contiv is a very active community. We are super interested in seeing people engage with us. It could be on the requirement standpoint. It could be in the development standpoint. So while we're doing that, so let me quickly show you kind of Contiv in action. So what I have here, an APIC. Hopefully it's still connected, and it is not. So let me log into it and get it going. Well, this is happening. So what I'm going to show you quickly in this demo, very quickly, is basically show you, what Contiv is, basically how I can create some Contiv policies, launch a couple containers, and then quickly show you an APIC what that'll create on the ACI side of things, assuming I can get my APIC up and running. I'll be doing that, but I'm holding my breath for this to load. While I'm doing that, let me quickly show you on the Contiv side. So what I have here, so this is just a basic Linux, Linux host. It's it's already running Contiv. It's going to be where I'm going to be running a set of containers. And the way you interact with Contiv, there's a couple. One of them is a VS CLI. There's a netctl CLI. And I can do things like netctl global info, and I can see how Contiv is configured. In this case, it's configured in ACI mode rather than the other modes I mentioned, like routed mode. It has a range of VLANs it'll use to communicate up, to the ACI fabric. This is how it signals different groups or EPGs, based on its policies. There's also a GUI. I'm not going to be showing the GUI as part of this demo. Usually in ACI mode, people use ACI as the GUI. In some of the other modes is where you can get more value directly out of the Contiv GUI, but that is also available for you to use. So if I was quickly show you kind of what an example policy might look like, I'm just going to show you, kind of via a quick script that we would run. Hopefully there's room to squeeze this on the screen. I was so worried about being small, I made it. So just to give you a sense of what Contiv actually looks like, in the end, what you can see here is, this is just a little bash script that I usually use to create some example policies, so I don't script the CLI. But in the end, the CLI is relatively straightforward to use. Contiv lets you create tenants. We have this concept of creating networks, which from an ACI perspective will do things like bridge domains. And then we allow you to create a policy, which is essentially a contract in ACI. And then I would create different policy rules. In this case, I have a very simple one. I'm just like allowing port 80 in this case. And again, my simple policy just lets like a group of web servers connect to client, connect to container clients. So Contiv would let me create my two groups. One group would expose the policy because it's essentially launched by ACI. And then when I create the app profile, it gets pushed into ACI directly. And then I can launch different containers, and I actually attach them to the network that maps to these groups that is created by our net plugin, and that connects them into ACI. So I'm probably not going to have enough time to go through this in more depth than to show you, but this would be the workflow that you would have through Contiv. That as you created these different things, it would, particularly when you do the app profile step, it creates the policy in ACI, and then essentially these containers are full ACI components. As they launch, they join a network that signals a VLAN up to ACI fabric, their EPGs, and you can do all the rest of the things that we've been talking about with ACI as a result. So what you see here is, Contiv allows us to connect ACI into, connect containers into our fabric, along with VMs and physical servers.